Okay. So chapter 9, and in chapter 9, we're looking at confidence intervals. So I just want to remind you guys about confidence intervals a little bit before we start getting into some of it. So just recall from step 1, when we're looking at confidence interval, what we're doing is we're estimating, right? So we're going to estimate either P, the population proportion, or we're going to estimate mu, the population mean. So remember, chapter 9 and chapter 10, that's part of the inferential statistics. And that just means that we're taking information from a sample and we're trying to project what's going on about the overall population based on that one sample. Okay. And sometimes we could do multiple samples, but the idea is that we have a sample, right? So that's what we're doing. We're estimating. So when you see that word estimate, P or mu or population proportion or population mean, that means confidence intervals. All right, so let's take a look at the confidence interval. When I say confidence, I will say confidence intervals, or sometimes I just say CIs, but I always just write CIs. I don't really write confidence intervals out. So CIs for the population proportion, which is P. I feel like that marker is a little light. Try a different one. I want to remind you, if we're studying proportions or P, that is categorical data. So there, maybe that's better. So that's our categorical data. So we'll remind ourselves a little bit, but this kind of goes off of Monday's lecture, or last class lecture, I should say. We need to be able to show that it's normal, right? We need to be able to show that we have a symmetric data set. So the way we do this is the same way as we did last class, where we have n times p times 1 minus p is greater than or equal to 10. But now we don't have P because that's the population proportion, and that's what we're trying to estimate. But we have a sample, so we have P hat. Okay, so we use P hat in this calculation. So if this is true, then normal. So that's a quick check. The sample proportion which is P hat, is equal to X divided by N. Now, X is the number of individuals that have a specified characteristic and N, again, is my sample size. P hat here is what we call the point estimate, which is just a way of saying it's the best estimate. For P, my population proportion. So we use that P hat in our calculation for our CI. So let's get to our formula for the CI. So our CI is always the same thing. It is point estimate plus or minus margin of error. Anytime we look at a confidence interval, we will always see that this is the equation I'm going to use or the formula I'm going to use. Then what we plug in changes based on the type of data we have or the type of problem we're working with. So every time we say CI, you're going to see me write point estimate plus or minus margin of error, okay? And so that you will just see throughout the semester. So here today, for the CIs for the population proportion, our point estimate is our best estimate. That's our p hat plus or minus. Now our margin of error is made up of two different values, which is z at alpha divided by 2 times my standard error. So z here is the number of standard errors away from the center. And the center here is p hat. So I'm going to rewrite this formula with my standard error formula, which will look very similar to last class. So I have p hat plus or minus this z at alpha divided by 2. And my standard error is that square root of p times 1 minus p divided by n. That's all under the square root. But we don't have p, right? We're estimating p. So again, we use p hat in this formula. Okay. So that formula for standard error should look very similar to last class. It's just now we're using p hat since that's the value we have. I want you to keep in mind the center of my curve is p hat, and the center is what you use here in this standard error formula, right? Because you're trying to find the standard deviation, right? The average distance from the center. So you're going to use the center. And again, the same idea behind checking for normality. You use the center of your curve always, okay? When you're looking at these proportions. So that's just a little reminder of what you use and when you use it. Now let's address this z at alpha divided by 2. Remember that alpha divided by 2 is just a location. You are not multiplying anything here. Alpha divided by 2 is just telling you the location. And what it is, this is like, you could call it your z critical value. You could just call it the number of standard errors away. I just call it z at alpha divided by 2. It's not like I'm multiplying or dividing. Remember what alpha stands for? Alpha is the area in the tails, right? And you divide it by 2 because you're looking at the confidence interval, which is in the middle, right? So when you're looking at a confidence interval, you have alpha divided by 2 over here and alpha divided by 2 over here. So let me just write that area in the tails. Just so you know what we're looking at, okay? The area in the tails depends on how many standard errors away we are, and that depends on our level of confidence. So we have different options for different levels of confidence, right? And we typically see 3 of the same, which is 90%. And then sometimes we see 95%, and some other times we see 99% for a level of confidence. So if we have a 90% level of confidence, that just means that Z is equal to 1.645. You don't need to know that here because Minitab is going to do this work for us, but it's just nice to know what's represented. If our level of confidence is 95%, then Z is equal to 1.96. And 99% confidence level leaves me with a Z of 2.576. Now in stat one, we needed to know these values or know how to find them because we actually use them in the formula, right? Maybe we did this by hand, this calculation, or we used our calculators, but we still needed to know what that is. When we're using Minitab, Minitab is going to give me these data values. So it's going to give me my confidence interval. I don't really need to know these numbers, but it's nice to know what this represents and where it comes from. Okay. So if I'm looking at a 90% confidence level, that means 90% of my data is in between these two numbers, right? And so that means alpha is 10%, right? It's 100 minus the 90. So I have 10%, I'm dividing by 2, 5 and 5, because it's centered. Okay, so that's what we're looking at, just to have a picture to go along with the formula of what we're doing. So of course, with that, we need to be able to interpret our findings. So when we're looking at Minitab and we just get these numbers, we need to know what they mean. We need to be able to put words to this. So if someone can just read our interpretation, then they don't have to go digging through the question to see what's going on. So the interpretation here, I just grabbed that bad marker again. Yeah, throw it out. The interpretation, and you are welcome to use just my blanket statement, or you may make your own, and that is fine. It doesn't matter. But I generally just say we are blank percent. So you put your confidence level here. Confident that the population proportion, that's all we're looking at right now, of, and then you have to have your context. So right here would be the context. So what the problem is about is between your lower bound and your upper bound. Okay. So you're just going to put your confidence level here, and then you're going to put your actual findings from Minitab here for your two values. Remember, you always put your lower bound and then your upper bound. So you always write numbers from smallest to largest. So on the left, you put your smallest number, and on the right, you put your largest number. I want you to keep in mind what we're doing when we're finding, when we're estimating this value. So what we're saying here is that if I was to build 100 confidence intervals to find this value of P, and I was at 90% confidence level, that means 90 out of 100. Okay, so 90% of those confidence intervals that I built will hold that value of P, that population proportion. Okay, and that's what it is. So it's not a probability. It's not that kind of thing. It's just that 90% of them will have that value of P. The reason why it's not a probability is because P is a set value, right? My population proportion. So if I was studying the proportion of people who are wearing white shirts today, that is a set number, right? It's a set percentage. It's not a guessing game. So that's why it's not a probability. So I just wanted to mention that. So whatever confidence level you're at, it's that percentage of confidence intervals will hold that value of P in them. Okay, we just don't know because we don't actually have that value, right? So we're 90% confident. And I also want to mention and just remind you from stat one, if you were 90% confident, then you have more area in your tails than if you were 95% confident, than if you were 99% confident, right? So if you are more confident, meaning you have a higher confidence level for your CI, that means your CI becomes wider. Okay. So it widens as you increase confidence. So it's not the idea that, oh, I'm more confident, I feel better about my answer. It's the same calculation all the time. It's not that. It just means I'm more confident because I'm including more numbers in my confidence interval. Okay. All right, let's take a look at an example, and we're going to work through Minitab and just see how we do the write-up and that kind of thing. So I'm going to switch my screen to our notes, which is day 4 today. And I forgot to write it down, I'm sorry, but I am going to look at example number 1, and that is on page 6 on those typed notes. Okay, so I'm already here because I pulled it up ahead of time. So when we're looking at this, just know when you're working with Minitab, you have 2 different types of data, meaning how data is given to you, summarized or raw data, okay? And I'm going to address both of those in the 2 different examples I do today, okay? So one in one example and another in another example. Okay, so in example 1 here, it says in the list of value survey that was completed a few semesters ago by RIT data analysis students, 31 out of 108 students selected that fun and enjoyment out of life is the value that they consider to be most important in their life out of all of them. And you can always go and we can, look at all of the information, but I didn't pull that up. I'm just giving you this piece and we want to study this. So in part A, it says, what is the sample proportion who selected fun and enjoyment as being most important? And then part B says, what is the estimated standard error? So this is my standard error I'm using in my calculation. And then it says, is it safe to assume that the sampling distribution is normal? So you can see parts A, B, and C are setting me up like what I did in the very first part of lecture today. Checking normality, getting my p-hat, and getting me my standard error. It's like setting me up for my formula, right? Keep in mind, we are not doing this by hand. We will do this part by hand, but we're not actually finding the CI by hand. We're going to let Minitab do it for us. So I'm just going to stop screen sharing this and we will address A, B, and C. You can always pull these notes up there, out there for you guys if you wanted to follow along or if you just want to watch and follow along this way, that works as well. So part A, I'm just going to write down some key information, right? So it says, that 31 out of 108 responded that fun and enjoyment out of life is considered to be their most important qualities. So that means that X is 31. So those are the number of people that have that characteristic, right? They answered that that's what they believe is most important. And it was out of a total N of 108. So this is key for us because this is how I calculate my p-hat, right? So p-hat is my point estimate, and that's my sample proportion, and that is equal to X divided by N, which is just 31 divided by 108. Now, yes, Minitab will give this to me, so I don't always have to do this by hand. It's just right now we're doing it. I think it means a little bit to us when we do this by hand, just a couple times before we just rely on our technology to do everything for us. I'm going to rewrite this and just divide this out and write it as a decimal because I'm going to be using the formula up here, if I could pull it down, and I will be plugging it into a formula, right, eventually, but I'm not actually going to do that by hand today. So 0.287037. All right, so they answered part A. Part B said, what is the standard error? So the standard error, remember I gave you the calculation for that here, and it is right here. So it is the square root. I'm just going to write it out here. P-hat times 1 minus P-hat, N. And that is the square root. So p-hat, I'm going to use that in here. Oops, you can't see what I'm writing, so my paper was down too far. 0.287037 times 1 minus 0.287037. divided by n, which was 108. So for my standard error, I have 0.04353. Now, I don't know if I rounded or what I did. I don't remember. I probably did. Okay. I have 5 decimal places there. So that's my standard error. So right here, I could actually go ahead and calculate my confidence interval if I wanted. Although I don't know what confidence level I'm using, right? And remember, it depends on the confidence level. My Z value depends on that. So I need to know that piece, but I have everything else, my p hat and my standard error. Percy said, is this normal? So is it symmetric? Because if it is, then I can go forward. If it's not, then I really shouldn't be going forward. Or if I do go forward, I shouldn't be trusting my results because they're not great, meaning I didn't meet my normality requirement, okay? So when I'm looking for normal, I'm just gonna plug into my formula, which is n times p hat times 1 minus p hat is greater than or equal to 10. So from here, n is 108, my p hat 0.287037, and 1 minus 0.287037. So I'm trying not to round too much, so I get an accurate answer, a more accurate answer, I should say. And this comes out to be 22. Yes, that's greater than or equal to 10. So I'm going to say, yes, it's normal. So I just do like a check mark. Yes, it's normal. What I need to see from you guys is this middle piece is what's really important for me to see, with this like check mark saying it's normal, or just saying yes, normal. So you're telling me it's normal, and then you're supporting it with what you did. And the reason why I'd like to see this is because I want to see what value of P you're plugging in, because as we keep moving forward, we're going to have different values of P, and it's important for you to plug in the correct one. All right, so I'm just going to share my screen to the notes again, maybe if I can find them, and see what part D says, since we've completed A, B, and C. So now D, I'm just going to write this down. It says use Minitab to build a 95% confidence interval. Okay, I'm just writing it down about the proportion of students who selected fun and enjoyment as being most important. Okay, and then it says interpret this interval. Anytime you build a CI, you should be interpreting the CI. Although on an exam, I do ask you separately. It's like a separate question. So I just wrote part D, 95% CI. Okay, so you can see this is what we call summarized data. So I have the number of individuals, I have the characteristic, and I have the total number of trials, or the total sample size here. So when we get into Minitab, you'll see we have 2 different ways we could go if we had summarized, or actually raw data listed out in like a spreadsheet. So let's go ahead and take a look at Minitab. I'm not sure if the steps for Macs are the same. So if you have a Mac, let me know if you're trying it out at the same time. So let's see here. I noticed if I have chats going on, that doesn't go away until I read those chats. Okay. So what we want to do is we want to build the CI. So I'm going to start at stat. I'm going to click on stat. And the very first option is basic statistics. I'm going to choose that option. Just scroll over it, and then I'm going to go over, and I have a drop-down box with a bunch of options. I'm going to choose one proportion. So you are at stat, basic statistics, then one proportion. One proportion just means we're studying proportions, and we have one sample. So that's what that stands for. I'm going to click on there. Now at this point, nothing's really going to pop up here, even if I click over here, because I don't have any data in my cells down here, right? So just keep that in mind. So this drop-down box says 1 or more samples, each in a column. That means I have raw data in a column. Or I could choose, oops, click on there. You could choose summarize data, and that's what I have, right? I have the number of people that said yes, that's what they chose out of a total number n. So I'm going to choose summarize data. And then you could see what my option here has now changed, right? So number of events is X, so that will be 31. And number of trials is N, 108. So just keep in mind, it's in the same order as you would calculate P hat, X over N, right? So it's in that same order. Now this perform hypothesis test, it's unchecked. You're going to leave it unchecked. Do not check that box. That is for hypothesis testing. We will do that next class. I do need to check on options because I do have something I may need to change and something I definitely need to change in there. So we're going to click on options. Now right here, I have my confidence level. So that depends on what level of confidence we're computing. We're using 95% and that is the default in here. So I'm going to leave it as is. I want you to realize alternative hypothesis. It set it not equals, that is the default. Not equals means it's two-tailed. Not equals means it's calculating that CI, okay? So we want the not equals there. And for method, I need to change this to normal approximation. So the one thing that I absolutely have to change every time is method to normal approximation. So make sure you take note of that. So I'm going to change that to normal approximation. Now I can go ahead and click OK twice and I'll get my answer. So right here, I don't get a ton of information out, but you can see a little bit about what's going on with the problem. And then you actually get some numbers down here in the second part. What I do, and you'll see it in the typed notes, I actually go to this drop-down box over here in the right, and I'll copy this whole thing. So it copies all of this that's here. Where if I just looked at this box, it's only going to bring this box over. From only in this box, it's only going to bring this one over. The key thing for me to see is really the second box, but it's nice to bring everything over because you get all of this. Because this part here tells me I change it to normal approximation, right? So if I'm reading someone's work and it says exact, then I know you didn't change it, right? That kind of thing. Okay, so let's just take a look at what we have in the output. We have N, which is 108, so that's great. We want to make sure that we typed it in correctly. That's my total number of trials or my total number, my sample. And then the event is 31. So those are the people that chose that fun and enjoyment as their most important characteristic or most important in life. And then sample P right here, this third value is my P hat. So my P hat actually is calculated for me in Minitab. So that's what I was saying. I don't actually have to do it by hand, but I was just doing it by hand in this problem. So right here we have that. And then right here, my 95% CI for P. So I'm just going to, over here on my piece of paper, I'm going to write it down. So I have 0.201719 up to 0.372355. And that is my CI. So now I need to interpret it. So I'm going to copy and paste this into my Word doc, and then I would interpret it. So I'm going to go back to my screen here. So you can see I wrote it. It's kind of sloppy and crooked. My 95% CI is 0.201719 up to 0.372355. So if we want to interpret this, which we always want to, I'm going to use the same statement up here and just fill in the blanks. So I'm going to say we are 95% confident that the population proportion now I got to add my context. So I'm going to say of students who selected fun and enjoyment out of life is between these two numbers. So 0.201719 and 0.372355. Sorry, I just squeezed it in there a little bit instead of going on to another piece. So this is an absolute must, the interpretation. When you're writing an interpretation, if you want to write it yourself, I'll tell you what I look for. I look for this 95%. I look for population proportion. I look for the context of the problem, and then I look for the actual answer. So those are the pieces that I look for when I'm grading. So it doesn't matter if you use my template statement or if you write your own statement, it doesn't matter, but those are the pieces that I look for when I'm grading a problem like this. Just so you know, those are the things that are important for me to see from you. Any questions on that problem so far? All right, so I have a question. So when we're looking at a confidence interval, we could have follow-up questions, right? So when we're looking at something like this, we want to make sure we can make other statements, not just interpret what it is, but make sure other statements we can, when we understand what the true meaning of this is. So I'm just going to tell you that it is fair to say that more than 20%, or I'm going to say more than 19% of students choose fun and enjoyment. Okay, I'm telling you that's a true statement. The reason why I'm saying that, I mean, you can say 20, but it was just so close. So I said 19. That more than is the key word. When you hear a statement about a CI and it says more than, that means that my entire CI is above. Okay. If you hear a statement that says less than, so I could say the statement that it's fair to say that the proportion of students who choose fun and enjoyment is less than 40%. That's a true statement, because that just means that the entire CI is less than that number. Or you can make an equal to statement. So I could say the proportion is equal to 35%. Or I could say equal to 37%. Or I could say equal to 21%. So I could say any number inside of the CI is equal to the population proportion. So we have several like follow-up statements. So keep a lookout for those, maybe on homework or on a daily assignment or even on an exam. Make sure you can follow up and make additional statements about this or state if they're true or not based on the confidence interval. All right, any questions on that one, guys? All right, so before we work on another example, I want to talk about majority preference real quick. This is kind of new. I don't really talk about this in Stat 1 so much. I may mention it briefly, verbally, but I don't really talk about it. So majority preference, or you might just say majority. This means that more than 50%, so majority rule, of responses feel one way. So meaning not a right or wrong, but just that there's majority of people said yes, or majority said no. That's what we're looking at. So we have three different scenarios. So if the entire, so this is key, entire CI is above 0.50, then the CI shows a majority. So my example for this could be something like 0.54 up to 0.63. That would be an example of my entire CI being above 0.5, right? Every number is above 0.5. So this is majority. If the entire CI is below 0.5, then the CI shows a majority, oops, for the opposing view. So what we're looking at here, if we have something like, maybe this is what we had in this example, 0.20 up to 0.37, right? So this is majority, but in the opposing view. So not the yes, the no's, okay? And then we have if the CI includes 0.5, then there is no majority. So just to throw an example in there, since we're doing that, we have like 0.49 to 0.70. Okay, it doesn't matter how close 0.5 is. If it's in it, it's in it, and it means no majority. Okay. So no majority is when it includes. Okay. All right, so those are the different scenarios for majority. Like I mentioned, I don't really do a lot with that in Stat 1, but it's just something that comes up a little bit more in Stat 2. Not that it couldn't in Stat 1, I just don't really talk about it much. I do verbalize it a little bit. Let's take a look at another example, and I want to show you a different type of, I don't want to say type of data, but I want to show you a different way we can see the data. So again, I'm sorry, I didn't write this down. It's example 2 on page 8. So I'm going to scroll to page 8. Here it is. And take a look at example 2. So it says a national survey of 900 women golfers was conducted to learn how women golfers view their treatment at golf courses. So you can find the data in the Tee Times Minitab file in my courses. Okay, so this file is right below the typed notes on day 4. I already went ahead and downloaded it and brought it into Minitab because I knew we were going to use it. So I'm just going to write down what A, B, and C is asking me so I don't have to keep going back and forth too much. So part A, it says build a bar chart and a pie chart. So I have a couple graphs I'm going to do in part A. Part B says, what is the point estimate? So it wants to find P hat. So it wants to find what is the point estimate for the population proportion of women golfers for satisfied with the times. So, and then I want to construct and interpret a 95% CI. So part C, I want the 95% CI. And then in part D, it asks about majority. I'm just writing this down off to the side so I don't have to keep flipping back and forth. All right, let's take a look at Minitab. So I'm gonna screen share this Minitab where I have the file in. So you can see it's a fresh Minitab and we didn't use it yet. And down here it has these responses. This was the Tee Time data. So you can arrow down and see you have a whole bunch and it should be 900, right? So the first part, part A, says let's get a bar chart and a pie chart. The reason why we do this is we want to get a feel for what's going on with our data, right? Similar to day 1 where we're looking at like histograms and box plots for that numerical data. This is categorical, so it's a little different, right? So here I'm going to click on graph. And I'm going to go all the way down. It's like a third up from the bottom. And you can see I have both, right, side by side, bar chart and pie chart. I'm just going to do the bar chart first, and then I'll go back in and do the pie chart separately. So bar chart, Here, you don't really have to change this often. Bars represent counts of unique values, function of variable. We don't ever really use that. And then values from a table. We will use that later on, just not yet. Okay. So unique values, simple. Then you're going to click OK. Once you click OK, it says it asks for my categorical variable. That's yes or no's, right? So right here, I'm going to double click to bring my response in, and I don't have to do anything else because this is just a visual. It's nothing really fancy. I mean, you can get fancy with it, right? You could change all the labels. I don't need that. You don't really need to do that. Don't waste your time on all of that. I just want to get an idea of what's going on. And look at right here. So my response, my no's and yeses. Look at. So before, we didn't have anything to say, well, which way was it going, right? Like we did with summarized data. We had no idea. So we have definitely more people responding no, that they don't feel that it's fair treatment for tee times for women over men golfers, right? So right there it is. No seems to be to outweigh the yeses, okay? So I love that visual. So let's take a look at the pie. It's different on Max, okay. Let me know if you guys can kind of get an idea. I tried to find the notes on this and I didn't see anything specific for Max. So I may have to have someone share their computer with me so I can see it, their screen in a little while. And I'll try to help you guys out. The pie chart, I'm gonna just click on graph and then pie chart, which was right alongside of the bar chart. I'm gonna do the same thing. I don't have table of values. That would be like yeses is like 500 and the no's would be 400 or whatever. It would be like that kind of thing. That's not what we have. We have raw data. We have unique values. I'm gonna bring response over to categorical. And again, I don't have to change anything. I have to be fancy. I just want to get something quick. And it's going to give me the same feeling. The no's outweigh the yeses, right? Look at the no's are the blue, the yes is the red. I have way more no's than I do yeses, okay? So it gives me the same feeling as the bar chart. It's just another way of getting that visual. And I like to show you both. Sometimes I'll just say, give me a visual, choose a bar chart or a pie chart. Just choose one that you would like to do. And you probably will have one that you prefer, and it's fine. And it's just that kind of thing. So I want to get P hat. So P hat, and I'm just going to write it down. So let me just stop this. My P hat, remember, is X over N, right? So if I'm looking at my X over N, and I'm looking at this, I want to see if I can actually get this off of Minitab, or if I'm actually going to go through and do sometimes. Okay, it just says 56 and 44. Let me take a look here. Here's some counts. Okay, so look at my bar chart. See how when I just hover over the no, it says there's 504 no's. And then when I hover over the yes, there's 396. That's what I need. That's my X. So X is 396 out of, we already said it was a total of 900 people. Okay, so right here, I can't put my mouse on it because when I move my mouse, it disappears. But it says bar group response, yes, value equals 396. Do you guys see that pop up? So when you hover over your bar, you can get that number of yeses and number of no's. So then I can come back to part B and I say, okay, I have 396 divided by 900 because it's X divided by N. And I'm going to find that that's 44% or 0.44 because I'm going to leave it in decimal. Okay. All right, let's go back to Minitab and let's calculate the 95% CI. I didn't check for normality. It didn't ask me to do it, although I should just do it automatically. But we're just going to go right into the CI. So I'm going to go back to stat, basic stats, one proportion. When I click on one proportion, same as the last time, it looks exactly the same, right? So here my drop down summarize data or it's in a column. It's in a column this time, right? So that's what I mean. I have my data given to me in a different way. It's in a column. So when I click in the box below, all of a sudden the response pops up. I'm going to bring that over by double clicking. Again, I need to go to options just like I did for that last example. Nothing new there. 95% is what we're asked for. I leave this at a not equals. I need to change this last one to normal. Click OK, and click OK again. Then here I get my response. So you can see that the event is the yes response that it's counting, okay? And then I'm getting my normal approximation method, and then right here I have all my output. So you can even verify that you calculated p hat the correct way, 0.44, there it is. And it gives me my n and my x, so it's the number of yeses. And it gives my CI. So my CI is 0.407570 up to 0.472430. So I'm just going to change my screen share here so we can look at this right up. I'm going to scroll down to the next page so we can see it. Oh, there's my charts. Looking nice. And then here's my mini tab output right here. And here's my little write-up. The point estimate is 0.44. And then right here, part C, construct and interpret the 95% confidence interval, which is what we just did. And now I'm going to interpret it. We're 95% confident that the population portion of women golfers who are satisfied, right? It's the yeses that we're looking at all the time. So it's always that yes. So that they are satisfied with the tee times is between 0.40757 and 0.47243. So now question D says, do we have evidence that majority of women feel one way regarding the availabilities? So I'm going to go back up to this right here. My answer, that's my CI. This is based on those numbers. And remember, majority means that either everything is above 0.5, everything is below 0.5, or it includes 0.5 means no majority. So we could see everything is below 0.5. So since every number in my CI is below 0.5, that means I do have majority, but it's for the opposing side, meaning that the women golfers, there's majority of women golfers who said no, that they're not satisfied, okay, with the availability of tee times. Does that make sense to everyone? You can see all the write-up right here in this